Yeah, it's okay. I think we can start, and more will join while I'm giving the introduction. So good morning, everyone, and welcome to this new season of the ETP4HPC webinars. It's actually our 15th ETP4HPC webinar today. I'm Pascal. I'm ETP4HPC's communication manager, and my colleague Maike is also here to help run the show if needed. Yeah, for those of you who are not familiar with ETP4HPC, we are a non-profit association that promotes European research and innovation in high-performance computing, HPC. And we are a private member of the Euro HPC JU, which is the organization in the European Commission that addresses HPC, to put it simply. And our role is mainly to propose research priorities for Europe in the area of HPC, of course. So I have a few practical information to share with you. Well, this webinar is recorded, and you will receive the link to the recording on Monday. This webinar is in listen-only mode because we have many people registered, so it would be impossible to let everybody speak. But you can ask questions, of course. To ask questions, please use the GoToWebinar control panel. There is a question panel where you can ask your questions, and you can submit your questions at any time during the presentation. And to make sure that everybody can see the questions asked, I will share them in the chat. So just look at the chat and you will see what questions the audience is asking. In the control panel, you can also download a handout. And today we have the slides as a handout. So if you want to have a PDF version of today's slides, you can download them directly from the GoToWebinar session in the handout section. And that's about it for the logistics. So yeah, no, one important point, we will answer questions at the end of the session. So let's get to today's agenda. We've had a lot of questions about Gaia-X and about its relationship to HPC. So we thought we'd better get the information from the horse's mouth, so to say, and that's why we're very happy to welcome today Pierre Gronlier, the CTO of Gaia-X. So Pierre will do the first presentation, and then we'll have the point of view of Carlo Cavazzoni from Leonardo. Carlo is well known to the ETP4HPC members since he's a member of the of our steering board. And yeah, finally we'll have two more members of the ETP4HPC steering board as moderators to guide us through an open discussion with you. And we're looking forward to your questions. So Jean-Philippe and Sai are here as moderators. And this program will take us to noon. We'll do our best to finish on time. So now I hand over to Sai. Sai, will you introduce Pierre?
Yeah, absolutely. It's a great pleasure to do that. So just a backdrop is this is probably one of the first times that we're having an active dialogue between Gaia-X and the HPC community represented by the ETP4HPC, and we really want to understand you know what Gaia-X really is about. We have heard bits and pieces of information, but as Pascal said, we'll really hear from the horse's mouth, so to speak, and it gives me great pleasure to have Pierre with us. And the goal is really to understand Gaia-X and understand the technical interlocks with HPC and what are the starting points of convergence and collaboration. So yeah, so we got Pierre here. So Pierre is one of the key people within the Gaia-X organization, and Pierre is the CTO for the Gaia-X AISPL. So he's in spite of his busy schedule, we've managed to get some bandwidth from him. Thank you, Pierre. So so Pierre's been in the IT industry for the last 12 years or so, and is working on operational side and scaling of systems in the field of real-time communication, and he's been in the world of the cloud services as well. And he has a penchant for science, and he has an academic background in embedded real-time systems and applied mathematics and signal processing and machine learning. It's very interesting here. And he started, it's interesting to see that you started as a research engineer in video compression, right, before you joined Skype and Microsoft. So it's interesting. You've been in you've been in the industry with some of the big players as well. So it'll be interesting to hear your perspectives. I'm sure you had all this in as you've worked on Gaia-X, you had this context. So he moved to the OVH cloud now in France, and that he moved to the OVH cloud in France as cloud solutions architect, and now he's the CTO for Gaia-X. So welcome, Pierre, and we really look forward to hear from you today. Yeah.
Thank you very much.
Yeah.
So, Jean-Philippe, do you want to introduce Carlo while Pierre is getting ready?
Thank you, Pascal. Good morning, everybody. Just reminding briefly our friend Carlo Cavazzoni, Senior Vice President of Cloud Computing and Director of HPC Lab at Leonardo Company in Italy. Formerly a very well-known and renowned expert in HPC at Cineca in Bologna. And by training, from an education standpoint, Carlo is a physicist and expert in material sciences. And very interestingly, is currently, in addition to being a member of our ETP4HPC Steering Board, is Leonardo representative in Gaia-X in particular. So it makes this makes his presence today a perfect fit and to talk, discuss, and present together with Pierre. Voilà.
So, Pierre, you should be able to share your slides now.
I am. Thank you. Please, could you confirm that you see?
We see your slides, but they are not in slideshow mode.
Yes, that one should work now.
Yeah, that's perfect.
Yes.
Thank you.
Thank you very much. Yeah. So thank you very much for the nice introduction, Sai. So indeed, there is a lot of things happening in Gaiax, and I'm very pleased to be able to share some of that today. So my name is Pierre Gronlier, I'm Gaiax CTO. I also put my Twitter account here in case you have questions. You feel free to ask either in the chat here, in the question panel, or Twitter. I'm available all the time. Today's presentation will be around one of the key deliverables of Gaiax, and one of the questions that is on the mouth of lips of a lot of people: what is Gaiax compliance? What does it mean? And it's, I think, very relevant for the world of HPC that is working on, for example, digital twins, the H2 cloud transformation. And every time you have processing, you have data, you want to be able to trace your data, you want to understand where it's coming from, what are the data usage attached to it. So the data lineage or the data life cycle, we'll say, including that we have this additional complexity of enabling exchanges of data across tenants, so across organization, so in an interoperable way. And it means that this interoperability is not only at the zip file or format file, but also at the identity level or the contractualization level. This is very important, I believe, for Europe. So accelerating, and that was one of the mantra of the association that was created, accelerating our European digital transformation in a sovereign way, or let me rephrase it, accelerating our European digital transformation while self-determining our level of autonomy. And I believe this is even more important than, to be more precise than sovereignty, self-determining our level of autonomy. There are two main categories that we see. Legal autonomy. So am I subject to non-European law? Am I subject to laws that are not from my jurisdiction I'm in? And technical autonomy. On the technical autonomy, there is two subsets, either hardware and what I will call virtual, but which includes software and data. There is a lot of emphasis on the data sharing autonomy, but the data, when we to extract value out of data, you need software, you need a process, a workload, an algorithm, and there is almost as much value in the data themselves than the algorithm that enables to extract this value. And this software and this data are subject to access rights and policy usage. So back to the first sentence that was self-determining or level of autonomy. To prove to have this level of autonomy, to have this control of our dependencies, not suggesting that we live in full authority in an independent way. I don't believe that's possible, but to control that level of autonomy on our dependencies, we need to be able to control our autonomy with regards to the hardware, which is out of scope for Gaiax, and everything that is related to the software and the data. And there is no level of autonomy if there is no capacity to understand and to have visibility, knowledge on where is the data, where is the software coming from, who delivers that software.
Sorry, Pierre, can I interrupt you just a second?
Sure.
There? Sorry. I was just wondering if you are moving the slides by any chance, because at least on my side.
Not yet.
Perfect. Thank you so much. Thank you. Sorry
in
about
one
that.
second, there is the next slides. I've tried to.
Yeah, thank you so much.
You're welcome. And that was the presentation of why we are focusing on this trust framework, something that was called Gaiax compliance before. Because we want to have this visibility and this, and trust is not something that is binary. So we need to have a way to measure that. And this presentation to emphasize that yes, HPC is there, processing data, and we want to have this level of understanding of what we are doing, because otherwise there is no digital twin in the digital space, there is no cloud, edge to cloud, and it will be extremely difficult to have this traceability of data. So trust framework and the compliance. When we hear the word compliance, that's what we have today. We have good certification body, qualification mechanism that produce, so I'm not trying to be provocative, but this is what I witnessed, a nice document that are not necessarily digestible for the end user. On the other side, we have in many different papers, including the one from the European Parliament, in a very well written one, which is only 10 pages. I invite everyone to read that. Digital sovereignty for Europe. They make a clear definition and expression of the need for, we need to ensure transparency and trust. So this is not how to become sovereign, which is part of a work for a sovereign person. I'm not. But our job in Gaiax is that how can we enable this trust and transparency? What is the framework that we can put in place? And by putting this framework, that might sound a bit abstract, but you will see that there has very concrete implementation available already. One of the fact that we have and to live with in Europe is that the European market is fragmented. And my vision is that this fragmentation that sometimes can be seen as a weakness should be a strength. Should be a strength because if we, and I'm quite sure that will happen, once we manage to have a common governance for all those atomic elements, what you can do is to compose them, to combine them, to assemble them together, to create more complex offering that will be far superior to any platform that we have right now. So this is a demonstrator. Those are screenshots. They're a bit blurry because I didn't have the original image of the catalog demonstrator that I developed in March 2020, already 2 years ago. And that's an example of what I meant by service composition. So you have a data set. Data set might be living on top of a database. Database sits on the bare metal. Bare metal is provided by a company located somewhere. And so you have a dependency. You have a graph of those dependencies. The bare metal server is also maybe hosted in one housing data center. And let's create another graph, and that you can combine together. It enables us to create a model of those relations. The services, the service provider. So again, this is coming from March 2020. The model that we have right now are slightly different, but the idea of service composition and assembling them together is still valid. So back to the service composition, what it enables us, and this is again a picture for the March 2020 demonstrator, it enables us to create a knowledge graph of a verifiable and composable signed claim. So it's based on verifiable credentials, technically speaking, but the important thing is that it enables to create a knowledge graph of those verifiable claims, to create more complex services out of atomic, more elementary services. Also, when you have this composability of services, what you can provide and measure is the portability of your services. And by services, I mean the software and the data. It also ensures, to a certain extent, depending of where we place the thresholds for the level of autonomy, the independence from the cloud providers. And I believe that's what was one of the main requests by every stakeholders for Gaiax, to be able to move workload, to move data from one place to another, but how to do that in a consistent, trusted framework. So that's what I'm presenting today. Service composition is at the heart of that framework. The next slides will present documents that are in draft. So this is something that will be released in Q1, but I believe this is so important that it needs to be presented before. The Gaiax Trust Framework, and here there is a big disclaimer, that's draft. We have this notion of a participant in the conception of Gaiax, a provider. Provider can be an HPC provider, can be a cloud provider, can be a provider for data sets. You have also the consumer, but the only one that we have specified so far is provider. And on the service offering, there is this model also of a composition of resources together. I will give an example later. For every, we don't go through the 90 detail of those tables, but just to show and illustrate that this is just not on the theoretical design. We do have a flat text file, so JSON file, therefore controls, that contains attributes that are signed, defined with a schema, with the terminology of every attribute that needs to be there, and who should sign also those claims. So this is really something that we are very intensively working on, and that will be the foundation of what will constitute this common Gaiax governance model. And this governance model is the first foundation layer to enable later composition of services at the infrastructure level. So the bottom of the red X part of Gaiax, and also the exchange of data, so the blue part of the X of Gaiax. That you will see in the next presentation. Let me summarize a bit. So the Gaiax Trust Framework also extremely important. That's what we call second order logic rules. So for those who are not familiar with formal logic, I will explain. When you are a set of claims that are key value or attribute value that are being signed by a cryptographic key pair attached to identity, what the trust framework rules will check is the content, whether or not the value is there, whether or not the machine, the claim itself, the value of the claim can be verified, is it machine readable. In some contexts, we cannot automate everything right now, so it will also can be just the base 64 of a PDF, so or plain English. And extremely important, who signed it? What is the identity linked to the signature of those claims? And that will give us the trust framework and a trust index that we'll describe a bit later. To give an example of this second order logic, then we can guess that there is an order, so there is a first order logic rules. The first example I'm giving for some times now is, imagine that Gaiax was a car shop. We will say in our catalog that all the car must have a color, but we will not tell what is a good color or a bad color. That will be up to the consumer to choose, the provider and the consumer to agree on which color they want to have. So car must be red, green, blue, whatever. And the same thing holds true for other type of attributes. So when we have data set must have a location, this is a mandatory attribute, that mandatory information that we have written down black and white in the trust framework. And the trust framework, again, to repeat it, this is the minimum set of requirements to fulfill in order to be part of Gaiax ecosystem. So if you want to provide a data set and be Gaiax, part of this Gaiax ecosystem, the location of the data set is mandatory. The next step then is for the provider, the consumer, or the labeling framework to filter, to apply constraint on the information, whether or not they want their data set to be located in, out, Europe, or another location. Same thing with the jurisdiction. And this is why, for me, this is important to go beyond just this name of sovereignty, because sovereignty can be interpreted in various ways. The information of who is the provider providing the location. The provider has a legal country of registration that have impact on this jurisdiction. We want to make that very transparent and explicit part of the trust framework. But again, this is up to the user to decide whether or not they want their services to be there or not. And the same thing we have, this is not something that is on that slide, but was on the previous slides. I made a strong emphasis on the software part. And here, for example, we have the main table, high level, a main table on the resource, and there is 2 types of resources that are described so far, 3 types. Physical resources, when we have the information of where the data is located at the country level for now, and virtual resources. And the virtual resources include everything which is a data set, a software, a configuration file, a license file, and so on. Those attributes, those items have a copyright owners. It means that to be Gaiax part of the ecosystem, when you provide a service, you need also to provide the information of who is selling you the service and the software. Because we really know now, and that has been in some news in newspaper for last year, a foreign state can decide to forbid a company to sell licenses outside of the country. And this level of dependency is something that should be visible for the users. This gives us the last slides, and then I'm done to present, and I very open to questions. Trust is not binary. This is something that you have to evaluate. This is a risk assessment. When you have an offer, you can describe what is your service provider. It's a participant. The participant can describe maybe additional information. So here I have a description, a JSON file, a YAML file here, but JSON, YAML, same thing. That describe one fortune teller. So an API that just return random messages. The same services can be expressed in different way. You can detail much more information than what you want, the bare minimum. So you can, for example, explain where is the data coming from, who owns the messages, where is the service running, who developed the API, and what are the legislation and the legal jurisdiction of all those providers together. It means that from this service composition, and now we are back to the first slide about service composition, this decomposition of the atomic element enables to create a graph. A graph is a mathematical object. And on this graph, you can compute metrics. You can compute the width of the graph, the depth of the graph, and you can give an observation, a metrics of based on, in comparison with other offer, are you less or more transparent than others? I mentioned also something that those claims are signed. When you have a key pair, you can derive key pair from one to another. And this length, you can also compute the length of this key chain. And this gives you another information of how strong the assessment of the claim are. Everything together, we are able to compute a trust index that is one of the deliverables for Gaiax. So to conclude on the trust framework, and I believe this is, so it was maybe slightly different than what you were expected, but I believe very important to understand how Gaiax contribute to the HPC world. Digital twins will require to have many sources of information. How do we aggregate the consent of those information? How do we compute maybe policy usage rights attenuation over time over the pipeline? So very important, trust framework doesn't take decision for the user. We focus on second order logic rules. We enforce transparency. By this enforcement of transparency on how services are composed, we enable portability. And we enable also traceability. So when you describe your policy usage and you grant your rights to someone, out of this policy usage, you can either transfer the same policy usage rights to someone else, if the policy usage allows you to do that. You can attenuate also the policy, so create another policy usage rights that have less stronger requirement. And because we don't want to have, I don't want to have another PDF hanging on the wall, this is automatable. scalable in a way that we are using W3C standard using data link. Data link, this is what's used in the web semantic, and we have huge corporation being billions of dollars on web semantic. So I'm quite sure that the tool and the software stacks is there and exists to support this kind of knowledge graph, really wide knowledge graph. And also, because our European economy is based on SMEs, 99% of our digital Europe economy is based on SMEs, it's extremely important to find a good solution for SMEs to be on board without going through a very formal qualification schema that usually takes time and it might be a bit expensive. Thank you very much. And I will be happy to take questions.
Okay, so we have just one question, but I think we will first have Carlo's presentation, maybe. Jean-Philippe, how do you want to do it?
Yeah, I think what I was thinking, maybe Jean-Philippe, you can confirm, is we can have Carlos talk as well, and then we can look at all the questions in one go. That may probably be a good approach. Pierre, is that okay for you?
Sure.
Yeah, Jean-Philippe.
Okay, then Carlo, are you ready to present? Are you going to share your slides, or do you want me to share them?
If I found okay, let me see if I can manage to share the screen. Now I'm sharing the screen, right?
Yeah, and now we can see a slide. Yeah.
Let me put in
But you're
presentation
not
mode.
Yeah, that's good.
Okay, so welcome everybody, and thanks for attending this presentation that will be about let's say the missing last mile on how to connect the HPC to what has been said about the Gaiax services, or if you want, I will try to indicate a way on how HPC could become effectively an asset for the Gaiax ecosystem, which is built around also the concept of data space. So to contribute to this marketplace where you can offer your capability, your capacity, or become a customer of other services, which is the infrastructure, the federated infrastructure, which will be based on the rule that has been already presented by Pierre just before. And so Leonardo is a company in aerospace and defense in Italy, and we are also quite active in the digital domain, and especially we are undergoing our own digital transformation and our own journey around the digital ecosystem, but we are also offering solution. And for those that maybe knows, we are let's say at the national level, we are going to present. We already have presented an offer for setting up in partnership with other a national cloud infrastructure for public administration, and the tender is out just in these days. So Gaiax ecosystem, we have the previous presentation was about identity and trust, but my focus will be on HPC asset, which was already as you can see in this slide, which was already considered as a part of the ecosystem, as in the infrastructure layer. Obviously, HPC, as you may know, can be it's quite a piece of infrastructure. Most of it in the next future will also be contributed by the European funds. So it's important to me that this asset will become more and more available to a larger community with respect to those that were natively HPC application and native HPC community, because the need of computational power. I hope you are seeing the change of slide, right? Because
yes, yeah.
Okay. So what we are assisting is that a growing need in the cloud for computational and processing capability. So few example we are witnessing on cloud and on distributed services, computational need for training of artificial intelligence models. So this is booming the request of GPUs on cloud and the offering of server or tenants with servers containing GPUs that many cloud service provider are adding to their portfolio of solution. You can go and buy directly let's say tenants with many server containing GPUs. Well, the cost is quite high, but this is now becoming more and more relevant for the business of cloud service provider. And then the question is, why not contributing to this market with also infrastructure which are already quite powerful and present in Europe, and as has been said many times, a percentage of the utilization of this machine could be dedicated to the market, to private customer, no, rather than a research institution. In Euro HPC JU, it has been said that up to 20% of the machine should be, in principle, allocated for commercial and private usage of the Euro HPC machine. So this is, I think, a way, the integration in Gaia-X, to extend the visibility of these resources and being allocated for services which can compete with those offered by hyperscalers, at least in the European market. A few examples, as I said, the training of artificial intelligence model, but also image processing. We have meteor radar, we have satellite images, and we have radar images from the satellites. We can be processed and contribute to important digital twins. As has been said, no, there is in Europe at least 2 large projects concerning digital twins continental wide, and are the digital twin of the human body and the digital twin of the Earth. And an example, image processing will be an important component of this digital twin. And those digital twin most probably will run computation inside the HPC data center. Other one are genome processing and digital twin, as I said, but not only, let's say, project like Destination Earth, but also maybe digital twin for private customers that would like to exploit the paradigm of the computation, not for a research project, but maybe for business. So let's come to the, if you want, to the central slide, the pitching the architectures, where we can have at the level of the cloud, of the marketplace, a virtual place, which is can be represented as a federated secure cloud. So Gaia-X is not an infrastructure, no, is not an iron. but it is a set of federated services that allow to compose the building block, as has been said, where one of these building blocks can be an HPC center. But another building block, very important for what we said before, especially about digital twins, are the data sources. So from one side, we have data sources. From the other, we have the HPC center that can do the heavy lifting of the processing. So we said that the training for the artificial intelligence and the digital twin. So obviously you can connect directly a data source to the HPC center, but you are losing in this way the possibility of sharing and of exposing services to a broader community. So the idea is to decompose this link, direct link between the data source and the HPC center, but federate them in a larger, let's say, space, which is the one of the data space, where you can also build a marketplace then over the service that you can deliver based on the processing and the post-processing of the acquisition. So data sources that we are seeing actually in our also internal infrastructure, and we will explain in a minute, we are targeting are let's say machine for genome processing. A lot of hospital and research, medical research institution are acquiring and installing this machine to sequence the genome of patient, and then you need to align and produce the genome and cross-correlate it with the other databases. You need an high power facility. Typically nodes, several nodes with a GPU today can do the job to fast process the data. And this can be done locally if maybe the hospital and the clinic is large enough, or this process can be delegated in an HPC center. In this case, you have where you have local data processes, you can do edge processing. Otherwise, you can have a trust with an HPC center and delegate the HPC center to process those data. And in this, let's say, delegation, it become important, as it has been said before, having a chain of trust that ensure the two parties to communicate together. Maybe in the past year, this happened doing, let's say, contracts, legal contracts with shaking hands between bosses and so on and so forth. Tomorrow, with proper marketplace, maybe you can do the same with a credit card, because you can base your trust on what has been said before, basically. So a digital document or a digital framework that ensure you the trust between the two parties. Other important source of data are satellite, but also in this case antennas for well-known large project that will need to share data across multiple institutions, and maybe multiple institutions that would like to post-process those data to be shared multiple times. Then, just to give you a specific example of what we are doing. So what is needed to link HPC to cloud? Partially, we have already been said. So identity and trust first has been already explained, but also compliance. So to build up a stack over the HPC to be compliant, then for delivering services, and to take part of a federated catalog. And let's say at least for the HPC I know located in Europe, the sovereign is enforced by the fact that the location is well understood and very well applied. on the other side, from the point of view of the HPC infrastructure, at least for what is the HPC of our own company, we have let's say a mid-range HPC cluster. How we have shared our infrastructure is by let's say offering resources of the cluster through two different if you want front ends. So the traditional HPC bare metal front end, where you can have SSH, a remote terminal or remote desktop where users can connect through SSH, or maybe more modern tools based on web application, so like a web portal or the Jupyter Hub, and this is already good for maybe connecting people to the infrastructure, but you also need the possibility to offer, let's say, services to the federated cloud. And for that, in our HPC, we have set up an OpenStack control cluster, which offers the same resources of the HPC cluster through the OpenStack tenants. So we can aggregate so compute nodes in two ways. So the traditional batch-like scheduler, or through the OpenStack tenants. So the same node. To do that, with respect to traditional HPC, what was needed in practice was to have two backbone and two different file systems. If you want, this is the little price to pay in order to have this setup. And the two backbone is InfiniBand, obviously for HPC, traditional HPC workload, and 100 gigabit Ethernet to aggregate resource with enough bandwidth to offer then tenants with an HPC capability. So we can offer tenants to the different division of the company, but also to some of the customer of the company, tenants where they can use GPU nodes to make processing of their maybe satellite data or genome data. The two file system infrastructure that you need to have, it's a traditional HPC file system, and maybe so a POSIX parallel file system, as we well know, over which if you want to export this data and to, let's say, show this data inside a data space which can be shared across the cloud, you may have to install storage gateways. In example, if you want to expose the data through S3 protocol. On the other side, for the tenants, the idea is to have a cloud native object store like in this case Ceph. And well, this allow our infrastructure to offer, let's say, if you want, two main view of the resource, and in this way we have extended the number of internal customer, but also external customer to the infrastructure, and to traditional engineer using CFD application or let's say traditional, also digital twin, if you want, to all other customers that are more data science and use big data tools and use artificial intelligence building blocks that typically are let's say are taken from the Apache-like ecosystem. So they need a native a cloud native tenant in order to quickly compose their application and to build their own service. We have already several data lake and services running on the infrastructure for our own business. An example, the business of helicopter, where we are aggregating all the data from the customer devices, so from the helicopter that we have and maintain for our customers, and all other data that comes from the factory that has manufactured the helicopter, the maintenance task, and let's say also the data coming from the flight recorder of the helicopter that can be downloaded and aggregated, and all these can only be aggregated and processed in a let's say relatively easy way if you allow the composition of those building block coming from the typical Apache world, and there are many let's say databases or tools that can process a stream of data and the like. On the other hand, the same resources can be used to share the infrastructure for more traditional HPC. So now we have these two cluster of different customer that, well, they also use different, if you want, they use different languages, and they are difficult. They have difficulties also many times to talk together in terms of infrastructure elements, because especially from the point of view of those that are on the application, on developing application. From one side, you have people working in C, Fortran, and the other people working in Python and Java most of the time. And so these require two different stacks at the moment to offer this data. There is a little chance of link, if you want, that is the use of containers. We have some experiment that was successful on, let's say, taking a container from the HPC world, so applications that have been developed in HPC, containerized, and moved to the cloud. This can work, and we have one case of an application that have been exactly been ported in this way. So, and in this case, the same application can serve, and the same code base can serve the two different community. One side on the living in a tenants, maybe inside a container, and the other living in the HPC bare metal, but again using a container. And that's it from my side.
Great. Yeah. Thank you.
Yeah, thank you very much, Pierre and Carlo.
And so Jean-Philippe, go ahead, please.
Yeah. We have several questions, so we'll try to take them now. For some of them, I think we progressively had from Carlo already examples or partial answers to those questions, which is very good, illustrating HPC, for example. So let's start with an early question by, let me find out, Henri Strauss, primarily to Pierre, but I think it can be answered by Pierre and Carlo. It's about HPC in the title of the first presentation. So could we give more precisions on the link to HPC? So I think Carlo already brought examples and reasons, but maybe Pierre and Carlo can quickly come back to that and confirm, give precisions on how Gaia-X and HPC can go together.
Yeah, from my side, as I said, at the moment, what you need is to comply to the rule, and the way we the quick way we were able to do that is through the provision of a tenant. Then we use OpenStack to provision a tenant to the outside world. But because if you want to share a service or expose a service, but then there may be other possibility that maybe I have not explored. But for sure, if you build up an OpenStack infrastructure, obviously you need to have all the running services of OpenStack beside the HPC. But then you can share the HPC node to the tenants of the OpenStack. This can be done. And as I said, you can share also workloads if these are containerized. Obviously, the container, in our case, was not opening sockets, taking data from different sources. It was an application to do a processing that where the input can be provisioned as an input file in the file system or through an API over the web.
Okay, thank you, Carlo. Pierre, do you want to add a short word on how you see link with HPC from Gaia-X perspective?
Yeah, I see the chat and I see many questions for Gaiax. Sure, HPC uses data. Gaiax is here to build a framework on how the data can be safely and securely transferred, exchanged. When you are doing HPC, you consume data, you consume software, and you need to have a framework where you enable different organizations to share, to trade, to exchange data.
Okay.
And also HPC also have this new that we see in some cloud providers, including in Europe, of HPC in the cloud. So HPC in the cloud, what happens when you don't want to invest a lot of CapEx in your own infrastructure and consume OpEx, but you need to make sure that which services do you consume, to which law does that it regulate? Because every time you are delegating something to someone else, this someone else can extract metadata. Metadata is also a source of information. What do they use this information from? Who do they sell this information to? So that's important.
Great. Thank you.
So I also have a lot of questions in the chat. Do you
yeah, I can. Yeah, sure.
Okay.
What I'll do is I'll try to combine some of the questions to save time. So, for example, there's a question from Joachim on what are the concrete implementation plans, and there's also a similar question from Anne Bernard as well. So, what are in terms of what are the milestones and the deadlines? So maybe Pierre, you can comment on this implementation plan at the moment and the critical milestones that are coming ahead of you.
The first roadmap that I presented are screenshots of the document that we are writing with since the beginning of January a lab. So we have a new team directly reporting the CTO to me inside the Gaiax Association, which is the Gaiax lab, and is here to implement, to prototype those services. So the first deliverable of the service that you will be able to submit a file and get back whether or not this is Gaiax conform or compliant, that's targeted for end of Q1, end of March.
Okay.
And this will unlock marketplaces, catalogs, all those projects that are eagerly waiting for being Gaiax compliant.
Okay, but maybe there are a few more technical questions to be made quickly afterwards, but then maybe let's try to take the question from Sabri Plana. It says, big tech companies already provide attractive services for users in Europe. How would Gaia-X address this condition, this kind of requirement?
As I presented during the presentation, those big players that are not mentioned have invested for the last 20, 30 years, billion of investment on platforms. The platforms are not composable, not interoperable, not usually always interoperable. And by interoperability, yes, if you move a zip file to another zip VM, that works. But if you try to transfer VM, you need to have interoperability at the network layer, L2, L3 network. How do you negotiate the subnets and those kind of tiny details that really enable interoperability and portability, this is something that the platform have no interest for. So yes, they will be able to market, to describe their services, but as I mentioned, their trust index, their capacity to decompose their services will be extremely low because this is not in their interest to do that. And this is what I said at the very beginning. In Europe, we have at the moment a fragmented market. I want to transform this, something that we can call weakness, into a strength where participants define their own interface using a common language, DSL. We have a lot of DSL for many different types of subjects. So we can have a DSL for this framework, domain-specific language, DSL, and make this fragmentation our strength for Europe. And I'm quite confident from the billion and thousands of different SMEs that we have in Europe, we will be able to offer the same or more services.
So if I may add, it's a pity that many times in the past for data sources, it was the only option to share the data to go to hyperscaler. So and and obviously the hyperscaler was eager to, let's say, offer service and solution, but as has been said, many times those solutions turn out to be legacy and closed, and your data, once there, the value of those data will become subject to the
whims and fancies.
There is this paradigm with what we call data gravity. And I would like to make a distinction between the data gravity, which is by itself not necessarily bad or good, that can be a need to combine data together, because some operation, when you are doing SQL queries, you need to have the data at the same place to be efficient. And this artificial data gravity, which is imposing extra cost for sharing, for extracting data, imposing rate limiting on APIs. Those are artificial data gravity constraints. And that is what we need to take care about. And you mentioned also before we had to move the data. I'm not aware of any silver bullet that fixes everything, but I can at least mention 4 technologies so far that enables to have a different way to process data. Compute to data, which is the simplest one. You move your workload close to the data, you compute it, you can verify what is being extracted of this network isolated sandbox eventually, and you can give out the results. Doesn't work every time. For example, to do a basic SQL join on 2 different databases, that will not work, so it doesn't solve everything. The second one will be fully homomorphic encryption, but it's complex. You cannot implement all the algorithm. It's explodes the complexity and the size of the data set, so that's to be handled with care. But it works very fine with small data sets where you want to keep the workload and the data private, genetics, for example, genomics. The third one is federated learning, but that's, again, you can apply that only to a subset of the machine learning algorithm. And the fourth one I know about is multi-party computation. But again, this is not a silver bullet. You need to rewrite part of the algorithm using a specific compiler. So there are ways to mitigate this leak of data to CSP. I don't know how to express that correctly, but there is no, so far, since we are using turning machines that basically just spend their time copying data from hard drive to the RAM, to the CPU cache, to the network, to the IP tram on the network. We have to find solution for every situation right now. I would like to finish by, in the real world, when you want to share an object, you move the object. In the digital world, when you want to share the object, you copy the object. And this is a fundamentally different.
Yeah, I think there's many. Thanks, Pierre. So there's so many questions, but we'll probably take 2 or 3 more, I think. So the question from Timio is, so within Euro HPC and other ecosystems, I mean, there's initiatives such as EOSC, European Open Science Cloud, that is. So there are some initiatives, but are there any efforts within Gaia-X to align those kind of trust frameworks that are already existent, Pierre? Would you have any comments on that?
We are working with EOSC together.
All right.
Then there is a saying that says a good software developer is a lazy because he tries to reuse. I consider myself part of that category, and if there is an association doing the similar work, we will definitely lean on them. And that answers the question on semantic interoperability, because there are already efforts also to do that.
Okay, so I see, well, time is running, but we have a few remaining more technical questions maybe. So maybe we can take 2 minutes to try to address them, or maybe this can be continued offline. But very quickly, we have questions from, I don't know, maybe for Carlo as well. Alexander Shabakov asks about OpenStack. Is it using virtual machines or bare metal nodes? Well, it's quite technical question. And another one is about InfiniBand network and the relevance or possibility to use it for the cloud as well, and not only locally.
So yeah, we at the moment we are using let's say OpenStack with virtual machine, because most of the workload running there are big data workload, and they do not suffer too much from the presence of a virtual machine, so over the matter. So we're using OpenStack, and as a service we deploy a tenant with already virtual machine, and yeah, with Linux, but it can be Windows as well. We try not to deploy Windows machine, but there are some applications that require them, so it's also an option. And about the InfiniBand, yeah, this is quite often what I'm discussing with those implementing the OpenStack services. So there is, in principle, nothing to avoid using InfiniBand. In the past, we have done also several experiments, but the problem is to find, let's say, distro that maintain the InfiniBand protocol and network within the InfiniBand service. I think that the InfiniBand service could be mostly useful for the file system, because for let's say the communication inside the tenant, well, you can expose directly the if you want, and if you need to do MPI, you can allocate directly the driver to the tenant. So it will be not virtualized use of InfiniBand. On the other side, you need also an Ethernet backbone, definitely, because most of the application and services use by default Ethernet, and it's difficult to change them to use InfiniBand.
I think, yeah, we are running out of time. Maybe Pascal will take one last question. I think so.
Yeah,
I
go ahead.
Mike
I think there is only one remaining, as far as I can see.
So yeah, so I realized this question from Mike as well. So so the question is probably a quick answer is: do you also work on semantic interoperability? So Mike asks. So any thoughts on that one?
As I said before, on semantic interoperability, no, we don't work actively right now, because we have first to lay down this foundation of trust framework. But I know that there are other groups of industrial and association that work on it, so we will lean and leverage their work. The semantic interoperability between the health sector and the energy sector, that's completely different.
This was what I was about to say. I think this work is being done within data spaces most of the time, because you need also within the same data space to aggregate data that in the past were being originated with different semantics.
Okay, thank you. I think there is only one question not addressed. Is it easy here?
Yeah, go for it.
Would it be another?
Go ahead.
It's about security. Would it deserve another full webinar? I don't know. what can be said, because the question is a bit precise and technical. If you can read it from Stefan Weinkofer, or is it a quick answer?
I can say quickly. This is inside Gaiax. If untrusted user via Gaiax, to that will happen, it means that a provider will have lose access control list, lose permission on his own network. And well, as much as I want Gaiax to be adopted by everyone, Gaiax is not a cloud provider, so we will be able to explain and to make sure that there is visibility, and maybe if we go even project ourselves way further, say, okay, you have a risk here, but that's threat modeling, and that's a bit out of scope for now. We are not here to configure the network for the for the participant themselves.
Great. Thank you so much. So I think Jean-Philippe, you and I are done here, I think.
Yes.
So
we have to give back the floor to Pascal to conclude.
Pascal, over to you then.
Okay. No, I just wanted to thank our speakers and our moderators today. And also I wanted to tell our audience that we hope to talk to you again in 1 month's time. Our next webinar is about task-based performance portability in HPC. That's a subject covered by one of the ETP4HPC white papers. So if you have an interest in this, please register. Just go to etp4hpc.eu. You'll find the link. Thank you, everyone, and have a good rest of the day and a good weekend. Thank you.
Thank you.
Bye-bye.
Look forward to collaborating with Gaia-X.
Bye.
Yeah, thank you so much.
Merci.
Bye.
Bye.